Hi Year 5, happy 1st of April 2020. Because it's Wednesday the 1st of April, what we decided was that actually we would cancel all learning today. So there is no video for you to watch today. You don't need to worry about doing any learning today. Just sit back, chill and do nothing. Only joking, it's April Fool's Day. Happy April Fool's Day. Of course we want you to do learning today. So, pinch the punch for the first month and no returns. So what we're looking at today then, well, we're looking at 3D shape properties. Now you've done this before last week, but Mrs. Ayton and I had a chat on the phone and we decided that actually you're probably not as good as you need to be. So we're going to revisit it, but I'm going to actually teach it to you first. And then you have got a couple of activities to do over the next few days. Okay, so first of all, a 3D shape obviously is made up of 2D shapes joined together. Okay, and you need to understand what a face is, what an edge is, what a vertex is, or vertex, that's singular, vertex is plural, and how to identify them within 3D shapes. Okay, so that's what we are going to be looking at specifically over the next couple of days. So here you can see this is my triangular prism, and it's got faces which are identified here, 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 and here. So it's basically the physical flat bits of the shape, or they could be rounded, I suppose, but it's the parts of the shape that you can physically touch and sort of put your hand on. Okay, so this triangular prism has 1, 2, 3, 4, 5 faces. Okay, so it's the front part, or as you rotate it round. So that's a face. Then you've got edges. Well, the edges join two faces together. Okay, they join two faces together, so you can see this part here is an edge. So we obviously got that one, that one, that one. Okay, and obviously as we go along there as well, we've got edges. Now, when you're holding the shapes, you have to remember the parts you can't see as well. So these are all sort of see-through shapes, but obviously if it was a one that wasn't see-through, my real bad artistic skills here coming through, you'd obviously have a dotted one along there as well. Okay, so you have to think about those faces and edges that you can't see all the time. Okay, so we've done faces, we've done edges, and then finally you've got vertices. Now vertices are just the points. Okay, it's the end or where two edges meet. Okay, so vertices are where two edges come together. It's the pointy parts, and again you have to be careful to make sure you count all the ones that you can't necessarily see. Now vertices is plural. Okay, so that means it's more than one if it's a vertex. The singular, so just one, is called a vertex. Okay, and some shapes only have a vertex, they don't have vertices. Okay, looking here then, we've got a cube. Obviously you know a cube is made up of lots of squares. The squares, the 2D part, put the squares together, you end up with a cube which is three-dimensional, 3D, so you can physically hold it in your hand, and you'll notice some cubes in your household. Well, I want to know how many faces, how many edges, and how many vertices does it have. Well, let's do faces first, and I'll actually number them. So we've got one at the back, one at the front, 3, 4, 5, and the bottom one 6. Okay, so we've got 6 faces there, and you can rotate it around obviously as you do it. Edges, right, edges I'm going to do in red. So we've got 1, 2, 3, 4, because that's a square. Square has 5 sides. 5, 6, 7, 8, 9, 10, 11, 12. So that has 12 edges. And vertices then, the points, which are 2 edges that join together, well, it has 1, 2, 3, 4, 5, 6, 7, 8, and it has 8 vertices. Now I'm hoping if I get rid of this that's the same. Yes, it is. Okay, so 6 faces, 8 vertices, and 12 edges on a cube. Okay, so imagine those as you go through. Right, moving on to the next one. A cylinder. You'll be able to find lots of cylinders in your home. How many faces, how many edges, how many vertices does it have? Okay, right, so then well, I can definitely see that there is a face there and a face there, so that's 2. And then there's obviously this circular bit here as well, so that's also a face. It's just a rounded face. Okay, so it's got 3 faces. Right, how many edges does it have then? Well, there's definitely an edge there. That's where 2 faces join, and there's definitely an edge there. There's no other edges, are there? This here is not an edge because it's not where 2 faces meet. So actually, it's only got 2 edges, which is that one and that one. How many points does it have? I can't see any points on that shape. Yep, it has 0 vertices. Okay, So it has 3 faces, 2 edges, and 0 vertices on a cylinder, sort of your baked bean tin that would be. A sphere, the shape of the Earth. You know I like science, so I thought I'd get that in there for you. The Earth is not flat, it's spherical. So what about this shape then? Well, this one looks a bit confusing. It's definitely got one face, which is there. Okay, I wouldn't be too sure about the edges. Doesn't look like it has an edge, does it? You almost want faces joined together, and it certainly doesn't look like there's any vertices either. So yeah, just the one face, 0 edges and 0 vertices. The sphere, the shape of the Earth. A cuboid then. Cuboids joined with rectangles or oblongs joined together. So if I try and count this one, then it's probably easier to do this one. How many faces do we have? Well, there's one on the top, one on the bottom. That's 2, these long ones. There's one there on the side, 4 on the side. We've got this one here on the edge, that one there on the 6th. So faces, it has 6 faces. It's a bit like a cube, isn't it? So I think it might have similar properties. Edges then, if I run my finger along there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all 12 edges. What about vertices then? Points. 1, 2, 3, 4, 5, 6, 7, 8, and it's got 8 vertices, which is the exact same as a cuboid, except this is a rectangle joined together, and the cuboid is just all squares joined together. Okay. Spot the difference then. What do I notice? Well, obviously they're different colours. Obviously they've got they're different shapes. I'm really interested in the roof. Okay, all the roofs of these shapes, and I noticed that this one goes to a point, that one goes to a point, but that one doesn't. Okay, it's got almost got a long roof on it as opposed to a pointy roof. Okay, it's got a long roof as opposed to a pointy roof. Well, the long roof, okay, and is a prism, and these two, like in Egypt, are pyramids. Okay, so if it's got a pointy roof, it's a pyramid, pointy pyramid, and if it's got a flat, long one like this, okay, it's a prism. And the properties of a prism, basically, this side here and this side here, so the two opposite sides. If it's a prism, its two opposite sides are identical. So that's triangular, and that triangular there are identical. So that's a triangular prism. This here is a pyramid. What's its base? Well, it's a square, so it's a square-based pyramid. And here is a triangle, so that's a triangular-based pyramid. Okay, so pyramids and prisms are different. Prism has a long roof, and a pyramid goes to a point. Okay, so looking at our triangular-based pyramid then, what properties do we notice? Well, I notice it's got faces, it's obviously got edges, and it's got vertices because it's 3D. So 1, 2, 3, 4 points, so it's got 4 vertices. Edges, what can I run my finger along? 1, 2, 3, that one there, 4, 5, 6, so it's got 6 edges. And then faces, well, it's got this one at the back, this one here, 3, it's got 1, 2, 3, and it's got this one at the bottom, 4. So I think it's got 4 faces, 6 edges, and 4 vertices. Okay. There's triangular prism, which is the one we just talked about. Slightly easier. Run my finger along there. So that's 2 edges, 3 edges, 4, 5, 6, 7, 8, 9. So it's got 9 edges. Okay, edges you can run your finger along. It's got 1, 2, 3, 4, 5 faces, and vertices then. How many vertices? 1, 2, 3, 4, 5, 6 vertices. Okay, 9 edges, 5 faces, and 6 vertices. Okay, so what about this shape here? Obviously it's a cone, you eat your ice cream off it, so faces, edges, and vertices. Okay, so I can see there's definitely a vertice there. I can run my finger around there, so it's definitely got one edge. Face, I can definitely see a face there. Now a face is where 2 edges meet. This is not an edge, so this point here going around there is not a face, so it only has one face, one edge, and 1 vertice. Remember, a face is where 2 edges meet. This point here is not an edge, so this bit here is also not a face. Okay, jumping down here then, square base pyramid, again, how many vertices, how many faces, and how many edges. Right, vertices then, 1, 2, 3, 4, and then that one 5, so it's got 5 vertices, 5 points. Remember, this is a pyramid because it goes to a point on top, as this one here was a prism because it had a long roof. This one here was a pyramid because it went to a point as well. Okay, so it's definitely a square, and it's a square at the bottom, hence it's a square base bottom pyramid. Okay, so it's definitely got 5 vertices. How many edges does it have? 1, 2, 3, 4, 5, 6, 7, 8 edges. And then how many faces? 1, 2, this one here, 3, 4, and then the bottom one is 5. So it's got 5 faces, 8 edges, and 5 vertices. Okay, so that's your properties of shape: faces, edges, and vertices. Now, some of you are looking at nets of shapes as well. Now, the net is obviously, if you imagine this cube here is made out of card, the net is basically how I'd make that cube with the card itself. And if I unfold it like this, take the roof off, and then I start to open it out, okay, I end up looking with a shape like this. So that is the net, okay, of a cube. Now, you'll notice that these are all squares because a cube all has the same side lengths, etc. Now, for a net of a cube, they don't all have to look like that, but you have to imagine folding it back up together in your head. Would it end up making that cube? Okay, so there's different nets you can have which will make a shape, but you just have to imagine, if I fold it all together, do all the sides meet? Okay, now this is a cuboid. Again, if I unfold this, so move down there, start to unfold it like this, that's what I end up getting, which looks a bit similar to this net, okay, except to this one, except obviously all the sides are different, okay. But that's the net of a cuboid, or a net of a cuboid. They're not always like that. And then a triangular prism, because it's got a roof like this, it goes along, so it's a prism, not a pyramid. If I unfold all of this, I end up unfolding all out, looks flat like that. And then if I go down, you can see that's how it looks. So there's your 2 rectangular sides. Okay, there's your 2 triangular sides. This point here obviously meets with that point there. Okay, which ends up linking to your faces, edges, and vertices, etc. So that's what it looks like if I was to unfold it out. So some of you have got that type of learning as well. So what's your maths learning for the next few days then? Obviously it's Wednesday today and it's due in on Friday. Right, well, we want you to go onto eSchools and see the maths activity that we've set you on there. It's called Maths 3D Shape Investigation, or 3D Shapes. This is what you have to do. So you're investigating a range of 3D shapes within your house or garden and write down their properties. So can you find cylinders, cones, cuboids, square base pyramids, etc. All the shapes we've just looked at on this table, fill them in. So for example, you might find something else here, fill it in, whatever it is. So for example, salt pot, how many faces does it have, how many edges does it have, how many vertices, and then what shape is it? And you can fill those in, find as many as you can. Okay, and then once you've done that, you can save it, file, save as, and then you can send it back to us, or you can take a picture of it, send it to us on eSchools, and let us know. If you can't do that, then you can just type your response on eSchools to us of what you found. I did give you a template of a table on your eSchools. When you look at your homework, you will see that. Once you've done the practical activity going around the house looking for items, then you can do the MyMaths work, which obviously you're pretty good at now. You can then do the MyMaths, okay? The MyMaths after, please, you've done the practical task, and hopefully your scores will improve, okay? So just the reminders then, which is due by Friday. You got your English, MIFS, which is due, the MyMaths. Now this is the only one that cannot be done on paper. All the rest you can do on paper, take a picture and send to us, okay? So you can send it to us for eSchools, Twitter, whatever. We can get it, just write it on paper. Obviously, you've got your Maths 3D shape task now, week 24, Maths, which is your red book, home learning, which again, you can look at it on the computer, write the answers out, send it to us. History, Jubilee work, reading comprehension of fails, and your SPAG, ABLE and IBLE, all of that due by Friday, please. So enjoy your next few days. Why don't you get some of your parents, because it's April Fool's Day, and we will catch up at some point over the next couple of days. Okay, good luck. Look forward to seeing what you find out in your home. Hope this has helped. See you soon.